Hello, this is Professor Gibson. Welcome to our Module 6 video about effect size and then linear regression. All right, so our main points this time, we're going to talk about effect size versus significance. What is linear regression? Some more about linear regression, and then looking back to last week's test on linear correlation. Effect size versus significance. So we've been measuring both in our reports, right? So statistical significance, often shortened to significance, is a measure of how likely it is that the result, I really should say the result of the test, is due to random error, just chance, luck, bad luck in this case, all right? How likely is it? That's what significance means. So when we say 0.05, we mean there's 0.05 probability that this result, or less, this result was due just to random error. Depending on the type of test, effect size, on the other hand, measures the relative difference between groups being tested, or the relationship between the variables being tested, or it's really the strength of the relationship, right? So the relative difference between the groups, or the strength of the relationship between the variables being tested. That would be effect size. If effect size is intended to measure, if you will, the practical significance of the results of the test, as opposed to the statistical significance. All right, what is linear regression? Linear regression is used to find the equation of the line that best describes the relationship between variables. I mean, if there is a linear relationship. This equation is only meaningful if the variables have a significant linear correlation. The equation of the line is usually written in slope-intercept form. It's like y hat equals mx plus b, where y hat is the predicted value of y for a given value of x. The x variable is called the independent or predictor, or even sometimes the explanatory variable. The y variable is called the dependent or the response variable. So what we're doing this week is a single linear regression, but you can do a multiple linear regression. And a multiple linear regression calculates the linear equation with multiple predictor variables, or if you will, multiple x's, and a single response variable. A little bit more about linear regression. A residual is the difference between an actual data value and the value predicted by the regression. You'll see one of our assumption tests is about the residuals. All right. What the linear regression process does is it minimizes the sum of the squared residuals. Because some of the residuals are positive and negative, if you just take the sum of them, I mean, it tends to add to zero, all right? So you have to square them to get something you can really minimize. That's what we do. And the linear regression minimizes that sum. You'll notice also in your results for this week, there's a thing that's calculated as a capital R squared. Sometimes they call it little r squared. It's the square of the correlation coefficient. It's really the same thing as from last week, but we're going to square it. Our capital R squared is also the percent of the differences between the y values that are accounted for by differences in the x values. And we're going to use it as our effect size as well for linear regression. All right, looking back at last week's linear correlation. Okay, so a reminder about what an outlier is. All right, so let's go back to the linear correlation. Here's the scatter plot of our points. We put a line in there just as a reference to see, with the line it kind of helps to see that the points do generally follow, right? And you look at this one down here. All right, SPSS doesn't tend to pick up outliers for a correlation like this. This one is out there a ways. I'd say that one's an outlier. We're not going to bother to remove it because even with it in there, you still get, as you'll see, I mean, the rest of them clearly follow the pattern of the line. All right, so SPS has two levels of outlier. We've talked about this before. Some are marked with an asterisk, and that'd be the extreme ones. the non-extremes are marked with an open circle. And again, in the case of a scatter plot like this, many times SPSS just doesn't pick them up. The decision to remove or not remove an outlier is a judgment call, all right? Removing extreme outliers and not removing non-extreme outliers is pretty common. And then my last comment on this last week's linear correlation test is an eyeball test of a scatter plot of the data, like we just did, we were looking at it there, to be sure the pattern of points essentially follows a line, is a meaningful part of the test for linear correlation. It's considered, you don't want to just look at the correlation coefficient. You want to look at the scatter plot, make sure, and just check with eyeball test to see that the points, the data values on the graph are, whether or not they are generally following a line. All right, so now it's your turn. This week we have our usual, practice reading homework, and then you're going to get to perform a linear regression. All right, thank you. That's it. This is Professor Gibson. I will see you next week.